Okay, Assalamualaikum. Today I want to present about least squares approximation. The title of our topic is the relationship between year and gold price in Malaysia since 2014 until 2023. Our group member are Faizwan Najmir, Muhammad Arafat bin Tajuddin, Amru and Muhammad Adam Daniel. Description. This section details the annual average gold price per gram in Malaysia from 2014 until 2023, highlighting trends and fluctuations in market during this period.
Okay, Assalamualaikum. So my name is Amru bin Muhammad Azri and I will be explaining about methodology overview. So understanding least squares approach. The least squares method is a mathematical technique used to fit curves to a given set of data points by minimizing the sum of squared errors between the observed values and the predicted values. So in this project, the method is applied to analyze trends in the data by fitting three different polynomial models, which is linear, quadratic, and cubic curves. First of all, the linear model represents a straight line relationship and is useful for identifying overall trends. For the quadratic models, it allows us for curvature and it is suitable when the data shows acceleration or deceleration. Lastly, for the cubic model, it captures more complex patterns by allowing multiple changes in the direction of the curve. So by comparing these three models, we can determine which curve best represents the data and provides the most accurate trend analysis. Okay, so first we will look at the linear model results. So based on the data set earlier, so we are given two sets of data. X represents the years ranging from 2014 to 2030, 2023. And Y represents the corresponding values for each year. In Maple, as stated in this slide, these datasets are entered as vectors X and Y. Therefore, these are the original data that will be used to construct the linear model. So we go to the next step, which is to form the linear model. We want to form the linear model in the form of Y equals to A plus BX as stated in the slides. So to do this, we construct matrix A, which contains the first column, all values are equal to 1, and the second column, which is the year values, are X. Then we construct vector B, which contains all the Y values. So in this case, matrix A and vector B are used in the least square method. So after we have defined matrix A and B, we will combine these two matrices into an augmented matrix M. This matrix is used to determine whether the system has an exact solution. To do that, we will reduce the matrix M to the reduced row echelon form. After doing so, we find that the system does not have an exact solution and therefore the best fit method is required to solve the system. So since the data earlier does not form a perfect straight line, we apply the least square method. In Maple, we first find the transpose of A, which is A transpose. In this case, we define it as AT, which is equal to transpose A. And then we need to calculate A transpose times matrix A, and same with A transpose times matrix B. After that, we need to find the determinant of A transpose times matrix A, which is equal to 825. And we need to find the answer, which is the inverse of A transpose times matrix A earlier. We need to multiply it with A transpose times matrix B, and we will have the answer. So next we need to solve the normal equations, which is N is equal to A transpose A augmented to the A transpose B. And then we need to reduce the N into the row echelon form. After that, we need to find the errors of the system, which is equal to b minus ax. So from the calculation, we obtain that the errors is 59.79. So after we have obtained all the errors and the equations, we need to display it in a graph position. Therefore, in this image, it is the point plots of the real data of the gold price earlier. So we point it using a diamond shape for each year, and this is the straight line which represents the linear best fit curve. And after that, we will combine the points earlier with this straight line, and we will have the best fit solution. And after combining the point plots and the linear straight line, we have obtained the linear best fit curve. So this curve is used to analyze the long-term trends in the data. And that is all. I will pass the presentation to the next presenter. Thank you.
Okay, next we move to the best fit quadratic curve, which is contained with a quadratic curve we need to find. So first we need to insert the x and y. So we insert x as the year and y as the price of the gold. When we fit in the maple, it will become like this. And next we need to make a design metric. So we use the A as a subject, so we turn it into the design metric, which is the first column we make it as 1, and the second column we make it as a year, and the third column is a year square. And then we can make y as b, so the y which is equal to the price of the gold. After that, we must find the vector space, which I use the maple to get the vector space, which is m equal to ab. So we get the vector space as you can see in the picture. And then after that, we must reduce the raw echelon form to see what solution that we get. After I use the maple, I get when I reduce raw echelon form of m, I get that there is no solution, because in the third row we can see we get 1, 0, 0, 0, 1. So there is no solution. So that we need to continue to find the error. In order to find the error, we need to find the A transpose first. So in the maple, I use AT equal to transpose A, and then I get the A transpose. After we get the A transpose, we need to find the A transpose A and A transpose B. So first, I search for the A transpose A, which is equal to AT times A, which is I get the A transpose A. And after that, I find the A transpose B, which is AT times B, and then I get the A transpose B. So we need to conclude it in one matrix, so which is I equal to N equal to A transpose A, A transpose B, which is equal to this. And then after I get it, we need to reduce the raw echelon form. When I reduce it, we can get there is just unique solution. After we get the unique solution, we can get that the equal of the last column, then the value. So we included z as the value. After we get the value, we must find the error, which is the error is equal to b minus a times z. And then after we get the error, we use the maple to find the magnitude of the error, which is magnitude equal to norm bracket error to and bracket, and then I get the magnitude, which is 45.47842312. And then we need to fulfill is the graph. So we must use the conduct, which is with plots. And then after we use it, I use the point plot, which is you can see as the picture. Point plot bracket xy color equal to purple, symbol less equal to 20, and symbol equal to solid diamond. And then we get the graph. After that, we need to find the plot graph, which is we use the z as our equation, which is the first row we make as a C,
and the second row we make as a bx, and the third row we make as a ax times 2, ax square. And then after we make the equation, we use the graph equal to plot G, and then we get the quadratic graph. After we get the quadratic graph, we display the point plot and graph and at the same time, and then we get the third graph.
Okay, next we have the linear and our control for the cubic model. So for the cubic model, we still choose the data, but x and we define y. Next, after we already define the x and y, our method, we will put it in form of matrix. So we need to define it as A and B. Since in matrix, it is AX equal to B. So for the A, we use 4 columns because this is cubic model. So for the first column, we put all 1. Second column, we put all the data in X. For the third column, we put all the data in X, but square it. And for the last column, we put all the data X, but we cube it. And for the B, we define it for the data Y in matrix form. Next, moving on. So since AX equal B, we have it as augmented matrix. So I define it as M. So here you can see I put it A and B, and the mapper already arranged it as augmented matrix. And then we just reduce row echelon form, and the mapper will help us to solve the problem. And as you can see, we get the no solution. Since we get no solution, so we have to do the step. First of all, we have to find transpose A. Why? Because we need to find ATA, which is A transpose A, and A transpose B. Next, we just put all the data in the mapper, and mapper will help us to make it. So our job will be easier. And then after we got it, we try to make determinant of A transpose A because we want to see if it will be many solution or unique solution. This is just optional. It's not a requirement, and it's just for us to see it. And then after that, we use the matrix inverse A transpose A times A transpose B. This is because we want to find what is X in AX equal B. After that, we repeat the same cycle, but we define it as N. So in N, we do the augmented matrix for ATA and ATB. This A is ATA, while B in AX equal B is ATB. And then, like I said, we define it in mapper and then use reduce echelon form. So the mapper will help us to solve it. Then we can see we get the unique solution. And then we need to find the error, which is the formula is B minus AX, which is we already define it as I define it as A and S, which is the answer. So put it in the mapper, and then we get the error. How many error we get it. And then after we get the error, we have to find the magnitude. So put it in the mapper, now in bracket E2, and the mapper will solve it and help us to find what is the magnitude of error. So that's good. We can see this is the graph and the plot for cubic model. That's all from me. Thank you.
Model comparison. Okay, here we have 3 types of model. The linear model, quadratic model, and cubic model. So for linear model, the error magnitude is 59.78. For quadratic model, the error magnitude is 45.47, and the cubic model, the error magnitude is 231838.35. Based on the three models above, the following error magnitudes in the correct approximation are obtained. The best fit curve in this case, which will give the best approximation, is quadratic model best fit curve because it has the minimum error in terms of its magnitude. For the prediction analysis, the quadratic model predicts significant growth in gold prices, estimating RM1,890 for 2024 and RM2,450 for 2026, indicating continued upward momentum. Prediction using the best model, that is quadratic. Okay, the quadratic model is given by the equation below. So for the year 2012, the predicted price is approximately -102,000 ringgit. For the year 2024, the predicted price is approximately 1,890 ringgit. And the last year, that is 2026, the predicted price is approximately 2,450 ringgit.